All right, sorry, I accidentally cut off that video, trying to scroll down a little bit here. All right, so we have to use a second formula for delta psi. All right, the equation for delta psi is going to be R times T over Faraday's constant times the natural log of a pretty complicated part here. All right, so we have sigma, which is the sum of the partition coefficients for our cations that are outside the cell. So C here is cations plus the sum of the partition coefficients times the anions that are inside the cell. All right, so one thing to be cognizant of, this A here stands for anions. The A's up here stand for whatever chemical we're looking at, in this case sodium. All right, over the sum here of the partition coefficients of the cations inside plus some partition coefficients of the anions outside. All right, so let's start plugging in this information now. So we have to calculate delta psi first before we can start calculating delta G. All right, so real quickly going to erase this and work up above here. All right, so our delta psi is going to be equal to 8.314 joules per mole Kelvin times our temperature, which is 298 Kelvin. Again, I didn't provide it to you in the problem, so I'll be flexible with that, but I'm going to use 298 or 96485. All right, now this is going to be multiplied by the natural log here of the concentration of our, natural log of these concentrations times their partition coefficients. So, all right, so let's start with our cations outside the cell. So we're on the outside of the cell, so we're going to use the blood concentrations here. All right, so we'll start off with potassium. So we're going to have 5, and I'm going to use E to represent times 10 to the negative, or times 10 to the power of, so E negative 7 here for the permeability coefficient, times 0.004 molar. All right. Plus, now for sodium, 5E negative 9 times 0.145 molar. All right. I'm actually going to run out of room on the screen. So I'm going to open up a OneNote page and continue this calculation in a third video. Sorry.